Welcome to Lesson 2 on recursion. And if you can believe it, this is one of our very last lessons that we're going to cover, even though we have a whole lot of time left. We need to get you ready for the AP exam. And so recursion is a very large and a very important topic that requires years really to fully grasp. So first, let's take a look at what is recursion. So if you Google recursion, well, I guess Google's not quite sure what recursion is, or rather, that's our joke. Recursion really is a way to break a problem down into smaller versions of the same problem. And so that's sort of the joke there from Google. And so, like it says here on the slide, to solve a maze, you can simply put your hand on a wall and walk it. And eventually you're going to get there. And if you try to write a procedural way of doing this and using loops, you would have to remember every single stop, every single turn that you went about, and you'd have this just incredible overhead of memory that you would have to self-manage. And recursion makes a very simple process to do this because it always remembers what it's tried at different levels. So realistically, what is recursion? Well, again, it's about breaking that problem down into simpler steps. So what is 5 factorial? Well, if you looked at it and you wrote it out, you'd see 5 times 4 times 3 times 2 times 1. Well, that's the exact same as saying, well, the whatever 5 factorial is just 5 times whatever the result of 4 factorial is. And well, what's 4 factorial? Well, 4 factorial is actually just 4 times 3 factorial. And so this is sort of what you do is you write these things out. We can also express it the same recursively with exponential power, or just simply writing a for loop. The key here is knowing when to stop. And so when you write a recursive function, the very first thing you do is you write your return statement, which is a deviation from typical standards and conventions. We want the return up high, at least one of them. That's another sort of deviation. With recursive functions, you might have multiple returns, or maybe you just fall out. But you want to have that base case. That base case is your get out of Dodge. How do you know when the problem is actually solved? So for factorial or exponential power, you know anything when the value is 1, right? Anything raised to the first power is itself 1. What's the factorial 1? Well, simply 1, and so you can just return the value 1. You actually know that answer, and that's what you're ultimately looking for. Is how do you know when you're done? So in the maze example, you would stop when you're at the exit. Otherwise, you would go through your recursive process over and over again. And so recursion can be a pretty big thing to wrap your head around. It's right up there with polymorphism. You'll encounter it across many, many programming classes. And it's a skill that you should lean into and try to solve things. And at times, a loop will do the job much better, much cleaner, particularly for the 2 examples that we had here with factorials and exponential power. But it's a simple way of getting used to doing the act. And recursion can be incredibly powerful and help you solve problems that you just couldn't iteratively. And so, welcome to recursion. Hold on, it's going to be a lot of fun.